was my one job. That's
Okay.
the reason I joined.
We are now recording. And take it away, dude. And you can tell us if you want to have questions during the talk or save them to the end, however you want, man.
All right. Welcome, everybody. Thank you for coming today and listening to me talk. My name is Matthew Bonig, and this is going to be about the AWS CDK from zero to hero in IAC, or infrastructure as code. So who am I exactly? Well, you can find me on Twitter at Matt Bonig. I am a system architect. I've been an application developer. Most recently, I'm a DevOps engineer. I work for a company in North Carolina called Defiance Digital, and our job is to help customers through both MSP and through contract work to better the customer's SDLC lifecycle. I am an AWS data hero, and I'm a founding member of the Open Construct Foundation. And generally, day to day, what I do is I build CI/CD pipelines and AWS workflows, and I use the CDK to do it quite a bit. So starting off at zero. Don't know anything about the CDK. What it is a API library that you can use with TypeScript, Python, Java, or .NET to construct your CloudFormation templates by creating objects, those objects called constructs, that represent things like a bucket or an EC2 instance or an RDS instance or an IAM role or any of those things that you can do with CloudFormation. Now we're just going to build those things using our common general purpose languages. And at the end, we just generate CloudFormation and then let that CloudFormation get handled through the system like we normally would. The central concept here is a construct. A construct is a class within the OOP, object-oriented programming world, that represents a specific amount of AWS resources. Most cases, that's going to be something like a bucket or an instance, something very specific, but they can be broader. They can represent lots of different things put together if we want to, or just a very small state. And we start to wire these things together to build out our entire AWS infrastructure that we need for any given application or workload. We're going to talk about constructs, and it's important to understand that there are basically three different levels of constructs in the CDK system. There are what are called L1 constructs, and these L1 constructs are generated from CloudFormation specs, and they are a very bare bones class, very anemic, very thin implementation, but they are available for everything that's within CloudFormation. So no matter what, you can always use those to generate out your infrastructure. They always start with the letters CFN for CloudFormation, but you generally aren't probably going to be dealing with these a whole lot in your day-to-day. L2s, level 2 constructs, are built by the CDK team. They are shipped with the AWS CDK, and they tend to be a little bit more focused. They do stay pretty much one-to-one in most of your cases. So for example, there might be an instance that represents an EC2 instance or a DynamoDB table or a database instance. But these L2 constructs start giving you a better interface to work with. For example, let's say I'm going to start up an EC2 instance. Well, I need to have an instance profile with a role, and I have to have all of these other things to actually make that happen. If I was going to use a level 1 construct, I would have to define all of those things myself. But when I go to use the L2 construct, it puts in things like smart defaults and creates some of these things for me. So it's much, much easier for me to create those resources. And I'll show you some good examples of that here in a moment. And then finally, on top of that, we have our L3 constructs. And our L3 constructs are what you will typically build on a regular day-to-day basis. You will use L2 constructs to do it, and you will build out these entire application workflows. For example, right now I'm working with a customer who we are lifting and shifting their ASP.NET applications into AWS. So I've built a bunch of L3 constructs that represents like their entire ASP.NET application and their databases and their CI/CD process and a DMS process to bring all the data over from the existing system. So L3s are generally what you're going to build. L1s, again, not really going to touch them a whole lot, but they are there if you need them. L2s is what you're going to really be dealing with on a regular basis. And then the L3s, they're as big as you want them to be. They can be very small in size, or they can be big, nasty things if you really want them to be. All right, once we have all these constructs together, again, we start wiring them all together. We say, okay, here's a bucket, here's a code deploy, here's a pipeline, here's a pipeline project and code build. We wire these things all up, and then when we're done, we hand them to a synthesize routine or a synth routine. And it takes all those things that we've created and it spits out CloudFormation for us on the back end. And then we use that CloudFormation through the normal processes that we normally have done in the past. So let's get straight to the demo, because for me, code says everything. So this is a sample project we're going to walk through here. We're going to start off, and actually I'm going to go back one step here. So this would be a brand new project started from scratch. Get out of here my Zoom window. So if you've ever done the CDK before, what you see here may be a little bit different from what you've done with the CDK bootstrapping when you create a new project. I'm using a project here called progen to create my CDK code. Progen is a side project that came out of the CDK. I can actually leverage all the same CDK principles in managing things like my source code, my package.json, tsconfig files, all that sort of stuff. Progen sort of helps me manage that a little bit easier, and I've been using it on all my projects since September of last year. I recommend you do the same. This is what it'll give me from the very start. So the first thing is we're going to create an app. This is a CDK specific idea here. There is no analog in the CloudFormation world for an app, but an app allows us to group stacks together within our CDK code, which is going to be very handy, as you'll see here in a moment. So I create an app to start, really don't have to tell it anything. I just create a new instance, and then it's going to create a new stack. In this case, it just boilerplates out the word my stack with some basic stuff. And then after that's done being created, it calls this synth routine. And the result of this would be some CloudFormation templates put into this CDK out directory here. The stack itself is a standard TypeScript object that extends this stack idea. This is analogous to a CloudFormation stack, although technically slightly different. And I just go ahead and putting resources in here. So this is what would give me what I get out of a basic bootstrap, but let's actually go ahead and move on to something that would actually be useful here. So I've gone ahead and replaced that my stack that it created for me with this thing called a VPC stack. Now, if I go take a look at this VPC stack, then the only thing that's really in here right now is this VPC construct. So I create this new VPC construct, and I'm not going to tell it anything more than just how many availability zones I want to have this VPC span in my particular region. I'm going to limit it to 2. It helps me reduce costs while keeping some redundancy. But you notice I don't have to really specify anything else in here if I don't want to. Now, once I've got this, I'm going to go ahead and run this synth routine on it. And the next thing I'm going to do is I'm going to use a really handy tool out there called the CFN diagram. And what it does is it'll take all of that resulting CloudFormation that gets generated from this, and it's going to give me a kind of a handy graph to show you so that we're not having to sit there and weed through JSON and YAML, which is really painful. So we'll do CDK out, and this one's going to be called the VPC. So we should just see vpc.template.json. So this VPC template.json, this is the file that the CDK is going to render for me and synthesize for me. So I'm going to let this run, and everything goes well. Here we go. So here's this. This is what I got with one line of code for the VPC creation. I have a basic VPC object here, and then I have things like NAT gateways, routes, route tables, subnets, all of these things created for me. I don't have to worry necessarily about getting those things all wired up. I just go ahead and let my L2 VPC construct do that for me. And if I want to, I can sort of change some of these parameters. Thanks to this being TypeScript and strongly typed, and IDEs doing their very good job here, I can see here, I can set things like with the side ranges for this VPC. I can say whether or not I want flow logs turned on, how many NAT gateways I want, and all these other values in here. I can provide them, and obviously the readability here is also really nice. So let's go ahead and move on then. Let me get all my changes backed out. Let's go ahead and add into this a database, because a VPC by itself isn't really all that useful. So if I go back here now, I have this VPC stack. I'm now going to add in this new database stack. And if I look at my database stack, what it's going to do is just create a RDS database instance. In this case, it's going to do a MySQL version 8. Now, databases have to live in VPC. So what do? I just take the VPC that was created in my VPC stack and hand it over to my database stack. I don't have to do anything fancy here with exporting a value from one stack and importing it into another. I don't have to worry about strings being passed back and forth. I just pass a reference to that object back and forth between here like I would with any sort of normal application TypeScript code. And the CDK will actually do all that magic work behind the scenes as far as creating exports and creating imports for me and all of that. But now I have two stacks in here, completely nicely separated from each other, but they are sort of, tied together a little bit useful. So there's my database. I'm going to go ahead now and add in an application stack. So again, the application stack is going to need to know a VPC to run in. It's also going to need to know the database instance. So I just hand those two parameters off to it. And now in my application stack, I've got real simple. I'm just going to create an auto scaling group in EC2. I'm going to give it a T3A medium. I'm going to use the latest Amazon Linux image from it. Notice here, I'm not having to specify AMIs. I'm going to let the system go ahead and figure out whatever the latest version of Amazon Linux I need. Now, this is kind of incomplete. This is demoware. Obviously, I would need to do something with my database instance. I'd need to, pass that to my application instance in some way and do something useful with it here. But I think you're starting to see the point as far as creating these constructs, wiring them all together, and the result of all of this. Let's go back here, and this time I'm going to go ahead and let's say I look at my backend template here. So the names I'm putting in here, VPC, backend, front end, these are just the IDs that I've been giving to the stacks along the way. So I'll go ahead and synthesize it. I'll go ahead and show up my diagram. And with my one line of a database instance construct, I get my database instance, I get my security group set up, I get, and this is really nice, it creates a secrets in Secrets Manager for me for the root credentials. So now I have my root credentials saved off in the Secrets Manager, and I can hand those around to application components as I need to. All right. So let's go ahead and move along to possibly the more interesting. Let's go ahead and add in, sorry, forgive me here, I'm doing a little code management. All right. So I've got that database stack, but the problem with the database stack is I don't want to actually hand over root credentials to my application. My application shouldn't be using root credentials to access the database. So what I want to do is I want to create a service account user in my SQL system. Well, that's not something you get for free with AWS. They don't have a resource in CloudFormation that will go off and create a user in your database for you. So I created one. This is a construct that I created. It's still technically demoware. I sort of just spun this thing up. It is publicly available. This is being pulled from NPM and installed via a normal NPM install command. But what this does is I give it a database instance to go access. I tell it the user that I want to create on that database instance, and then what logical databases within that instance to grant access to. Behind the scenes, what this will do is create a custom resource within CloudFormation. It'll create a Lambda, and then it'll wire those two things together and hand these parameters over to the Lambda. When the custom resource is created by CloudFormation, it'll send this information over to the Lambda. The Lambda has the logic wrapped up within it to go ahead and create that user on the database. It also creates a database secret and other things for me, so I can leverage those things later.
Matthew, can I just jump in and say that is amazing? There's a whole class of problems. Are you going to take it? I mean, this is amazing as it is, but I'm thinking about things like creating indexes, initial data population, all the stuff that you normally can't do in CF or TF or wow.
Right. So yeah, and in the lift and shift project that I was talking about earlier, so I have other constructs that do things like create those databases. So I get, this is SQL Server in my case. So I get SQL Server, I get the master database, but I've got a couple of, application databases I have to create. So I've wrapped those up into constructs with custom resources and Lambdas and all that accordingly, so that those things can be handled in a very, very deterministic way, thanks to CloudFormation, rather than having to sit there and run all these scripts and stuff accordingly. All right. So
Can I ask one more quick question on that while we're on that topic?
sure.
Does CDK, the custom resources, do, I'll call it a better job of managing? Like, I hate custom resources because you'll put a bug in it and then you hang up your stack for like 8 hours or whatever it is. Is there, catch handling in CDK that helps sort of reduce that?
Not that I've seen, no. You still have to be careful when you're working with custom resources to make sure your handler is properly sending responses back to CloudFormation so that you don't have those things. That's still unfortunately a problem. However, it would not be hard to start to write a construct that sort of solves some of these problems for you. Probably be a worthwhile thing to do if you came across that problem more and more. But really, that all comes down to just writing your handler correctly. And that's a tough thing to try to generalize because everyone's handler is going to be a little different. All right,
Yep,
so let's
thanks.
show you. So this is, here are, I've now used some L2 constructs. The VPC I would actually consider an L3 construct. And now I've also used a third-party construct that I pulled from the public internet. And we'll talk a little bit later about the construct catalog, a third-party cataloging system that was built to scrape NPM, find these constructs, and surface them so that you can go out and search for what other people have already built and leverage them within your CDK code. So finally, let's go take a look at another really, really cool construct. This is called the CDK pipelines. Now, if we go through here and I look back at my code, there's been quite a little bit of a change here. Basically, I still have the same sort of stuff. I create my app, I create a stack, I synthesize that. If you're not familiar with TypeScript, don't get hung up on a little bit of the magic code that I've got right here. This is all just to facilitate making database calls and other things. And we'll come back to this here in a moment. But this pipeline stack now, this that I've created uses this construct called a CDK pipeline. Now, what CDK pipeline is, it's a construct specifically built to set up a code pipeline for your CDK code. So now that I've dropped this in here with this one construct, I create a couple code pipeline artifacts, but I basically have the CDK pipeline right here. And then I defined application stages. And application stages are an environment that I want to deploy my CDK code to. So this could be in another account. This could be in a different region. In my same account, doesn't really matter. This handles cross account deployments just fine. So in this case, what I've said is that I want to set up a pipeline now for all of this code that is wrapped up into this thing I call my super app. And I'm going to deploy it out to this same account in this case. But if I want to, I could override this and point it at a different account. And this goes and creates all of the CDK pipeline stuff for me. And really automates the process very, very nicely. In fact, let's go ahead and take a look at exactly what it's going to create. So we'll synthesize, this will render out a big CloudFormation template again. And then when we look at it, what we're going to start to see is it's going to create a lot of stuff for us. So this is what the CDK pipeline construct creates for me. I've got things like a bucket. I've got bucket encryption keys. Well, let's simplify this view a little bit. So I've got, let's get rid of some of this stuff. So I've got a bucket, I've got a code pipeline, I've got a code build project, and all of this is pretty much turnkey. Now, if I was to go ahead and deploy this stack out here, now I have this full CI/CD pipeline for my CDK infrastructure. Really, really super cool construct. I use this on almost all of my stuff now because I don't want to be manually deploying or manually running CloudFormation anymore. All right. So ultimately, everything that I've shown you here at this point is stuff that with a lot of effort and good experience, you could probably do with CloudFormation by itself or with something like Terraform or other sorts of tools. I want to show you something, though, that is going to really take this to the next level and show you things that you can't do with any other language and any other IAC. So the first thing we're going to look at is the case where I want to actually be sort of, I'll call it being reflective. So in this case, I'm going to create a stack. I'm just going to call it a microservices stack. But think of this like a microservice application or a big serverless based application. You're going to create all these constructs. You're going to create all this stuff. And at the end of the day, you're probably going to have a lot of lambdas in there. And you want to monitor those lambdas. You want to be able to know that they're not throwing errors, they have certain rate limits hit or whatever along the way. So what I've done here for completely demoware, you'd never actually do this in real code, is I'm just going to go ahead and toss 9 Node.js functions, 9 Lambda functions into this stack. Now, in this case, I know what all my Lambda functions are, but once you start dealing with these constructs more and more, you may not know that there are lambdas being deployed because it's abstracted behind those constructs. So how would I go and monitor something if I don't know it exists? Well, first thing I'm going to do is I'm going to create a new CloudWatch dashboard. Standard L2 construct for my CloudWatch dashboard here. And then this is a custom construct that I wrote up called Lambda metrics. And all I'm going to do, if you notice, the only thing I'm telling it about is the dashboard. If I go look at this code now in here, what it's going to do is it's going to go into the stack in which it's defined. So it's going to take a look at its current stack that it's been added to, and it's going to go find all of the children, all of the constructs that have been added to that stack. And then I'm going to use a little bit of fancy duck typing and TypeScript to say, okay, what are all of my node functions, or what are all of my Lambda functions that I have added to the stack? And then for every one of them, I'm going to call this little helper function that exists on the function construct called metric errors. This gives me a metric specifically for that function's errors. Creates it for me. I don't have to worry about creating that construct or that little object or anything else. The Lambda function creates it for me. And then I'm just going to add it to a graph widget and then add that graph widget to my dashboard. So now what I'm going to get, I'm going to go back here. We'll go ahead and render this out. What did I call this? Microservices stack. Okay, so what I'm going to see here is I'm going to see my 9 Lambda functions, and I'm also going to see all of those Lambda functions now tied into a CloudWatch dashboard. So now I immediately have a dashboard. I didn't have to worry about what Lambda functions were there or anything. It just automatically reflected on the stack and gives me a control over all those dashboards. And I could extend this pretty easily with a few simple lines of code to do some other things. Like, for example, what if I wanted to alarm on set up alarms for any time those errors passed a certain amount? So let's say one error in one data point, I want an alarm to go off. Well, it's basically adding one line of code here that says, now that I have the metric, go create an alarm off of it, and that alarm notifies to an SNS topic. And this is a construct that I could then drop in and make available to all of my teams within an organization so that they can very easily have the proper monitoring in place for their Lambdas from day one. And you don't have to constantly go down and chase them afterwards and say, why didn't you put the proper monitoring in from day one? All right. So I don't think there's an easy way to do that with anything else. If I'm wrong, let me know, but very cool little feature there, and the power of having a general purpose language at this point. All right. Now let's go back for a moment and let's talk about those service accounts that we had earlier. All right. So going back, I had my database set up and I created this database user in here, but real quickly, you're going to find out, oh, well, I have other users that I want to have grant access to my SQL database. Maybe it's other service accounts, but maybe it's actual developers. And I want to go ahead and make sure that they have a proper SQL user on the system that they can log in and access it. So all I have to do is go ahead and take that construct and create 3 new ones, one for Julie, one for Shriram, one for Steve. Creates the user account in there. They all have individually their own secrets that I can then grant access to those users and say, okay, here's your SQL username and password. It's in this secrets manager, and we're guaranteed that that's maintained against the database properly, and there's your access. Now, that's really cool, really flexible. But here's the thing. This code actually sucks for one particular reason, because if a new person comes into the organization that needs access to that database, a new team member, maybe the team member leaves, maybe the new team member comes in, I, as the DevOps engineer, have to come in and modify this code. And that's not good. That's a dumb process to put into place to manage these users. It's going to be someone's manager that says they should have access to the database. Why should the manager have to open up a ticket to DevOps, have DevOps work that ticket into their schedule, go in here, copy and paste 3 lines of code, commit it, push it, do all that stuff, work the ticket? Like that's just unnecessary cruft work. So how can we make that better? Well, the first thing I'm going to do is I'm going to refactor this a little bit. I'm just going to rearrange the code. It doesn't fundamentally change the way that it works. It's just going to reorganize it a little bit. And the first thing I'm going to do is I'm going to go ahead and instead have an array of those usernames and then just iterate over that array and then create a new database user this way. So a little bit easier here, a little bit nicer. If I have a new user that comes into the system, I just have to add their name to this array. But again, I would have to do that as a DevOps engineer. That doesn't make sense. I don't want these usernames to be here in this code. So what I'm going to do is I'm going to pull this property up. Literally what I'm going to do is I'm going to take these values and I'm going to sort of bring them up a little bit and make them as part of this properties that is passed in to the database stack. All right. So what that looks like is now our code, instead of iterating over an array that was hard coded in, now it's just going off of the props and an array called usernames. All right. And now the usernames are defined back here in this file rather than within the database stack itself. So we just rearrange things. We're not really changing any functionality at this point. We're just kind of moving things around. But the reason why I move it around to here is because now I've got the ability using Node to get this information from anywhere. I could get this list of names from a local file. But what I think is more interesting is actually going ahead and getting this information from DynamoDB. So what I'm going to do is I'm going to make it so those usernames come from this function called getUsernames. And getUsernames is going to go off to the standard AWS SDK for DynamoDB, and it's going to scan a database that I have in the system called SQL users. Now, SQL users is a standard DynamoDB table, and it really only has one column on it called username. So I'm going to get all those users out of the database, and then I'm just going to return a list of those usernames that came back from it. And I'm going to have that now be what drives the creation of those constructs and synthesizes this all out. So let me show you, hopefully, if I have this all still set up right. And this is where doing a live demo can really bite you. Now I'm going to go ahead and diagram this out. And again, we'll call this backend. So my code is actually going out, querying DynamoDB, getting back that list of users, handing that over to my stack. And now I have this synthesized stack. Now, again, lots of stuff right here. So let's go ahead and sort of clean all this out a little bit. Let's go with just our custom resources for now. That should be good. Right. So we've got custom resources for Shriram, for Julie, for our service count, for Steve. And if I start looking in there, I'm going to start to see that those are tied to Lambda functions. Those Lambda functions are tied to the CloudFormation resources, to the database instances, to secrets, all of this stuff. So now I've got this really slick system where a manager doesn't have to come to a DevOps engineer and put a ticket into the system because someone joined the team. They can just go into a DynamoDB table and add that record. That's all they have to do. And that can be done any which way you want to, through a dedicated UI or through the manager being smart enough to just go into the DynamoDB console in AWS if you want to do that. Now, there is one additional step here, of course. I would have to make it so any change to that DynamoDB table caused a rebuild of this process. But because I have this wrapped up in that CDK pipelines construct now, all I have to do is write a really simple Lambda that listens to that DynamoDB stream. And anytime something comes across that DynamoDB stream, now we're just going to go ahead and kick off that pipeline, and everything else is taken care of. Now a manager can do this, and you can set up your notifications and everything. So they put the record in the table, and 6 minutes later, they get a notification that the pipeline is done and the user is all set up and really good to go. So super awesome there, really, really helpful. All right, last thing, which I think is really fun, and this is going to probably be useful to some people who are doing any of the serverless functionality. So if I was going to go and deploy out, say, API Gateway V2, want their new HTTP API. So I've got a RESTful API that I want to deploy to the public internet. It's going to respond. It's going to be kind of a little microservice, and it's going to be backed by a bunch of Lambdas along the way. Well, I like having my serverless code really, really close to my CDK code. So I'm going to go ahead and actually put all of those Lambda functions. And I know this is probably really small on your screen. There was no way I could blow up the text over here. But over here, I've got in this directory structure called APIs, all of my various Lambda handlers. And these are just really generic Echo handlers. There's nothing actually going on here. Again, demoware. But I've got these handlers set up here. Now, normally I'd have to go in and create my HTTPI construct and then start adding these routes in and say, okay, for my customer route, when it's a delete method, I want to go hit this index.ts handler. And when it's an invoice route with any HTTP method, I want to hit this index handler and that sort of thing. But that's really bothersome because it means that as a developer, I'd have to go write the handler, I'd have to go put in this directory structure, and then I'd have to go tell my CDK code that I did that. But that's dumb. Why do that? So what I'm going to do is I wrote this construct up that goes through and uses this get routes function here. And get routes, if I could find its code properly, get routes, all it does is it goes and parses this directory structure, parses the files that are in it, or looks at the file names that are in it, and returns back a basic structure. And it's going to look at the first level directory and take that as the route. And then it's going to take a look at the second directory, the one down from that, and it's going to take that as the method of the handler. And then the file itself is just the entry point for my Lambda function. So it's going to go through here, look at all of these guys, return back this big array of routes. And then I just, like I did before with my users, I just iterate over all of those routes, adding each one of those into my HTTP API along the way. All right. Cool. So I've got all this built out, which means that now if I want to go ahead and add a new route into the system, let's say I add in a new order route, and I go ahead and add in another any method call there, there's nothing in my CD code I have to change. I just add the handler in with my application functionality. I go ahead and let's see here, customer stack. Let's go ahead and synthesize this so you can see what it looks like. But it's going to automatically pick it up during the synthesize routine. I don't have to explicitly tell about the code. It can actually determine from the environment, from the directory structure, what's there. So if I go take a look at my routes, I can see here, I've got my customer any, I've got my post customer, I got my delete customer, my get customer, I got my default route, I have my customer any, yes. And then I've got my integrations along the way. So all of these things tied together. So from a microservice deployment standpoint, there's some big benefits here. So I don't have to constantly be double managing things because of course, when we shifted to this serverless, what we really did was we took a lot of the code that was in our application layer and we made it part of our infrastructure. We still have to care about that, generally speaking, but now I can let the CDK care about a lot of that stuff for me. All right. So that's how you can start doing some things with the CDK and that you've never been able to do with any other IAC. And you can hopefully be a really cool IAC hero with this whole thing. All right. Now, one thing that I didn't really touch on, but it's a big part of the CDK, and I'll kind of leave it to you to explore afterwards, is the fact that all of this is just general purpose code, whether it be written in Python or Java or C# or TypeScript, JavaScript. You know, this is general purpose language application development languages that we have been working with for years. And we have a lot of great tooling around it. We have a lot of great information on the public internet in terms of Stack Overflow and blogs and all that about how to do interesting things with it. But also we have the ability to unit test, which is something that you really don't get with a lot of infrastructure as code. There isn't really an integration testing with Terraform or with CloudFormation. Really, if you want to make sure things are working the way you expect them to work, you're going to be doing integration testing. So you're actually going to deploy those out to an environment and then evaluate the environment afterwards and say, is this correct or not? And that's a big pain. And it also really restricts you from creating very robust, very great CloudFormation templates or Terraform modules or other things, because the amount of time it takes to test those things on any sort of iteration is way up. So you can do unit testing with it. I didn't highlight any of that here. There's lots of good examples about how to do unit testing with the CDK. But what that means for you as a developer and as a DevOps engineer is that you can build these constructs, you can unit test them, which means that it's much, much faster to start really fine tuning your constructs, making them work well. You are open to refactoring them and rearranging things and taking useful parts of a CDK app that you've built and pulling them out into publishable constructs that you can give to the rest of your team, that allows for these really complex compositions and a lot of really powerful things. And you can do it much, much safer. If you start to get to the point where you've got a lot of like if logic into your construct, so you say, okay, well, when I'm working and this stack is being deployed out to my dev environment, then I want there to be a Bastion server to be available. But if I'm deploying to a prod environment, I don't want there to be a Bastion server. Well, in the old school, you can write that logic in a lot of ways, but it means that you would have to deploy it out to the dev environment and make sure that you got your Bastion server. And then you'd have to deploy it out to your prod environment to make sure you didn't get a Bastion server. And if you're wrong, you're in trouble. Well, now you can just unit test that and say, okay, does this particular resource even show up in the CloudFormation template? Don't have to worry about any of that. All right. Very, very powerful. If you're going to publish a third-party construct to the internet, I highly, highly recommend you unit test it. Not just any Lambda functions that you go with it, but actually unit test to make sure it's creating the resources you expect it to. A lot of times when I'm building constructs for either my own projects or for clients, a lot of that complex logic doesn't really fit in, so I don't end up writing unit tests for them because I'm basically declarative code anyway, and your payoff isn't quite as high. All right, so finally, I want to leave you with some resources. If all of this sounded interesting and you want to continue down the CDK path, first place, these are in no particular order. I just like the way that it sort of looked on the screen when I put these in here. And if you're following along with the presentation with the link that I posted in the chat, these are clickable and I'll take you straight to them. CDK.dev is a website that was started last year as a community hub for a lot of the CDK work that's being done by the community. There's also a Slack channel that is pretty active. I think we have over a few thousand people who have joined into it now, and we have really, really good community support in that Slack channel. Everyone's always out there trying to help each other with CDK problems. When we're looking to doing some very interesting things with the CDK dev website to try to make it a more powerful and useful community resource. There's the AWS CDK.io. This is the construct catalog that I mentioned earlier. This is a place where you can go to find published third-party constructs. If you want to go and say, oh, I need something that will, for instance, shut down an RDS instance every night because it's a development environment, I want to reduce costs. Well, you can go to the AWS CDK.io and find that construct there. If you are new to the CDK and you want to go through a workshop tutorial, the cdkworkshop.com is great from AWS. There is, I hope I'm saying this right name, Colamede. He has a GitHub page called the Awesome CDK, where he really tries to also take a lot of the things from the community and highlight some of the really nice stuff that people have been putting together for it. And then finally, there is the CDK docs. This is a pinned tab for me. I always have this thing open. I'm always going back to the docs. So get familiar with them. One thing that I would recommend if you're going through the docs, let's say I want to go look at API Gateway v2. This will list out all of the various constructs that are available within that module to use. However, the overview of any given module is where you're really going to find all the good stuff. So if you want to know how to properly spin up an EC2 instance within AWS, well, start with the overview because there's probably an example in here of how to do that nicely. All of your good examples and stuff will likely be done here within the overview section of a module. When you get into the actual classes themselves, you get some strict definitions, but these are all generated off of source code, and they're ultimately nice references, but doesn't really help you get started on stuff. So always remember you got that overview here that gives you a lot of that really good stuff. All right, that's it for me. Hopefully that wasn't too quick and everyone followed along. If you have any questions at this point, free game, open up your mics and throw me any questions you got.
I didn't know if there was any spots you wanted to compare or contrast CDK with Terraform, particularly around state. Like I don't know CDK myself, but people say, well, you know, you run it twice and you have two stacks, right? Because it doesn't know state. It's just going to create another one. But more generally, TF versus CDK.
Right. So the CDK, the way that I usually pitch it to most people is it is a generation framework for CloudFormation templates. At the end of the day, you are still dealing with CloudFormation. You are still dealing with CloudFormation state management. It's change set management. It's all of it, any of its limitations in CloudFormation. You're still going to have those with the CDK. Thanks to custom resources and other things, you certainly have some nicer ways to work around those issues, but for the most part, it's still going to be CloudFormation. So, the big difference between Terraform and CloudFormation when it comes to state is that Terraform exposes that state, and you can actually manipulate that state to make band-aid fixes to deployment problems or to sync up existing resources with new ones that you're creating in Terraform. And you don't really get that option with CloudFormation. And that's probably the most significant difference between the two. Under the hood, there's also a difference with the fact that Terraform is effectively using the AWS API to make any sort of changes to resources. So if I ask for a new EC2 instance, under the hood, Terraform is making an API call to bring that up. Whereas CloudFormation, that's all under the hood. You don't know how exactly it's doing it. And if you want to manage something via CloudFormation, it has to be supported first in CloudFormation, or you have to do it yourself through custom resources and things like that. Whereas with Terraform, they can sometimes adopt things faster than CloudFormation because AWS rarely deploys something out without the API support there, although they do often deploy things out without the CloudFormation support there.
Thanks.
Yep.
Matthew, I wanted to comment on your construct on doing alarms for Lambdas. And I actually did that in something basically the same sort of thing in Terraform, but it took me 30 lines. So I would have much, yeah. Now the thing is, this bit of code, you wrote that. Everybody else can just call it, right?
So I wrote this code. This is not a published construct. If I was actually going to make this something better than demoware, it would be a little bit more complex than this. This is pure demoware here. This is proving a point, but there's a lot of little things about this that I wouldn't go and ship this to people with. For example, this little bit of duck typing that I'm doing right here, this sucks. This is the fact that TypeScript is a pseudo object-oriented programming language, and it's not a runtime object-oriented language. So I kind of have to fake it with this. And there are certainly some probably edge cases where this would fail inappropriately for you. And I would actually add in a lot of features and other things to this. So you could define things like how big do you want your widgets to be, if you want to pass parameters to the metric errors, because of course I can come in here and start telling this Lambda function, well, yeah, I want a metric for your errors, but I also want some of these things specifically set up, like what's the period that I care about, what's the label for this metric, and those sorts of things. I haven't provided them. So yeah, if you are interested in this or that database user construct, if people have some interest in that, hit me up on Twitter. I'll be glad to try to productionalize it and publish it and make it available for everyone to use.
The database one I'm going to talk to you about.
Okay. The database one I'll need help on because it would have to be database agnostic. It would have to be able to work on MySQL, SQL Server, Postgres, all those things. And right now it's only coded to work on SQL Server because that's what I needed at the time.
Yep. And the AWS CDK.io is another place where you might look for these constructs, if I understand correctly.
Yep, absolutely.
Yeah, okay.
Yeah, as far as I know, it's the only place you could probably find them, short of you going through NPM yourself or hoping that Google would point you at them. The CDK.io, the construct catalog, really was trying to scrape NPM, figure out what constructs have been built, and then surface them so that no one's trying to reinvent the wheel too much.
Sounds good.
There's actually a couple of them up there that are now deprecated because they've effectively rolled that functionality into the CDK directly. For example, one of the first constructs I built was a Lambda function that specifically for Node.js automatically applied the HTTP reuse flag for the AWS CDK, which makes DynamoDB calls significantly faster, and generally any API calls to the CDK or to the SDK faster. Well, they've now rolled that into the general function within the CDK itself. So that particular construct's, no longer needed.
And how quickly does the CDK adopt some of the newer technologies, like say, EFS support and Lambda functions, and be able to do that?
Right. So let's go take a look here. I want to highlight this about the documents. Let's say I go in here and I look at the CC2 module. Well, these are all these constructs that have been built for all these L2 constructs that have been built. Notice there's like a Bastion host Linux. So this is a specific type of EC2 instance that is meant to get you into a Bastion Linux host very, very simply, things with like SSM agent installed and all of that. So these are L2 constructs. However, they don't have L2 constructs for everything within AWS yet. Those require manual development work. They require thought about the APIs. They go through an experimental phase before being API stable. If I was to look at like the data migration services module, DMS, there are no L2 constructs in here. There are only the L1 constructs. I would have to work these things up, and all of my code would look almost identical to anything that I wrote up in CloudFormation. So for a lot of the very popular services and a lot of the popular modules, a lot of the L2 constructs are there, and there is good development effort that's being put into those. A lot of the edge stuff, though, basically anytime you look at a module over here and there's this little one subscript, I know it's probably really tiny on your screen, but there's this like little one right here next to it. That means that it's only got L1 constructs on it. And you're going to be fighting a little bit when you work with those, because you have to care about dependencies yourself and all those sorts of other sort of unfortunate things. They are actively working on L2s all the time. There's a lot of effort. Mostly it comes down to what people are asking for. It is also an open source project. So they are always willing to take PRs from anybody in the community that is building these things. And they're very good about coaching you through how to build an L2 construct so that they have a nice API, so that they are reusable, and so that they cover all those sorts of things. Hope that answered that. Not a great answer, I'll admit.
It did, thank you. It's good to know.
The other thing I noticed there is that even on those L2 constructs, sometimes there's just a time lag between the updates of new features. Like you mentioned the API v2 gateway. I was doing a CDK project at Christmas time there, and I wanted a Lambda authorizer on an API v2 gateway, and there was no such a thing. So I just did it myself with the CFN constructs, and got it working eventually. But it was a little bit of noodling around, just thinking, well, I can do this in the console, but I can't do here. But it all makes sense. Obviously, as you say, it's a moving target, and AWS changes the functionality and adds new features so quickly that
And the CDK team runs pretty quick. They are typically doing a release about once, if not twice a week. And those releases often include new features, not just bug fixes, but new features along the way, which sometimes, not always, but often means new constructs. So it's one of those things where you do if you're going to be developing with the CDK, I highly recommend that you try to keep up with the CDK version as much as possible. And unfortunately, unfortunately, that means that as you upgrade from, say, version 9.0 to 9.1, there may be some breaking changes in your code, because maybe you were using an L2 construct that was still in the experimental phase, and therefore they've changed the API and introduced a break for you. But if you keep up with these things along the way, then it's typically a very small amount of changes you would have to make when a new release comes up. And if you don't do this, then what can happen very quickly is you find yourself 6 months behind on the releases. And if you need to update because there's an L2 construct now available that you want to use, you may suddenly have a day or two's worth of breaking changes you need to fix. So it's a fast moving API. You're going to have to kind of live with that and try to keep up with it as much as possible. Most of the projects that I work on are at most maybe 10 to 15 versions back. I try to keep up with them as much as possible.
I was hoping to get your idea on also, like when you segregate out different apps, Like I normally would do within one app, I'll have like, okay, my dev, UAT, prod, and like I'm just passing in like tags to separate them out. But then it starts growing larger and larger. It's like, any recommendations there?
A great question. It's been asked quite a bit before, and I don't know as though I have a great answer for you because a lot of it's going to be very specific to what you're building. But generally, how I end up building out my stacks. So if I go back here to, let's go back to a better example real quick. Let's do this one. All right, so in here, I've got a VPC stack, I've got a database stack, and I've got an app stack. And I separated them out here, and this is a typical pattern that I'll use on a lot of my applications. I separate them out this way for 3 reasons. One, a VPC is something that I probably will never have to touch after I initially created. Hopefully I created it right the first time and I don't have to change it, because the fact is if I do have to change it, like my CIDR block was wrong, well, I'm probably gonna have to blow everything away and recreate it from scratch. So I keep that in its own separate stack. A lot of my applications have a VPC stack in it, and most of those VPC stacks literally have this one or so line in it. So very, very isolated there. For the database and for the applications, again, those are kind of isolated based on whether it's the logical separation of my application. I will often have things like a stack dedicated to either DMS or some sort of data migration along with it. I may have a separate stack to handle the CI/CD process around my front-end application or my back-end database. I try to isolate them and separated them out a little bit more than less. Better separation because, one, I can more strongly guarantee that if a change is going to be applied to a stack, that I know exactly what that change is. And the 2, I'm not applying a change to a stack that isn't needed. When I set up that CDK pipelines and it's going to go through and try to deploy all these stacks out to a given environment, I don't want it to sit there and be spending 20 minutes deploying one stack and then find out at the very end there's a problem and it has to roll back and I got to wait another 20 minutes. Keeping the stack small will help me feel less pain from any sort of problems during those deployments, helps me from a headspace standpoint understand what's in the stack and what I should and shouldn't put in there. But there is a balance there. You don't want to have 35 stacks. When you do start to get into these interdependencies between stacks, for example, the database stack has a dependency on the VPC stack, you can run into some difficulties because of the nature of CloudFormation with those dependencies. For example, if I go ahead and deployed this entire application out, I could not delete the VPC stack because the database stack and the app stack depend on it. If I have this database stack here, and I delete the database instance from it and I remove that, I can't automatically deploy that out because the application stack has a dependency on it. There are ways around this. There are some tricks and tips, and if you want, I can point you to some blog articles. But at the end, there is a balance that you will have to find for yourself about too few stacks or too many. When in doubt, I usually start with having too many and then consolidate them if I'm running into dependency issues or other things. So one thing I wanted to mention before I forget it, when we're dealing with this, big complicated stack here, we've got a database and app stack, we got the CDK pipelines and everything. I don't remember where I put the numbers, but if I remember right, it worked out to being 300 lines or so of code that I had to own and maintain here within my CDK application, translated to, I think, 12,000 lines of CloudFormation code that I no longer had to manually maintain. To me, that is the number one reason why I use the CDK, because like C and assembly, or like Java and C, there is a huge gain you get along the way in going to a language that abstracts a lot of these things. And the amount of code that I have to own, the amount of code that I have to be able to wrap my head around, it drops significantly, which makes it a lot easier to maintain, a lot easier to understand, and just makes for a better experience for me all around.
Your comment about keeping up on the change in the CDK, it sounds like the pace of change in the CDK is still high. And for somebody who needs to maintain infrastructure and does 9 other things as well, that to me is a little bit of a concern.
Yep.
So I'd be curious to find out how, I mean, you're saying you need to keep up, but how big an issue is that? Or is that a reason to maybe look at other tools?
So I don't personally find it to be too big of an issue. The projects that I'm working with, I've probably, for the company that I work for over the course of the last year, I think there's been about 2 or 3 projects which I've used the CDK pretty heavily on. And in those cases, keeping up with the API changes wasn't too difficult. Now, one of those projects has basically been untouched for about the last 3 months, 3 or 4 months. So I know that if I'm going to have to go in and do any work on it, I'm going to probably have to dedicate a little bit of time, maybe at most a half a day, in making sure that the CDK is bumped up to the current version, because at this point, let's see, 3 months, that'd probably put it about 20 to 25 versions behind. So I know that bumping up 20 to 25 versions, I'll probably have a few breaking changes along the way. Nothing that's going to take more than a couple of minutes on each one to probably fix. And because I try to get unit tests around stuff when it's appropriate, it should be pretty simple to do. As long as I always try to do it when I go back into my CDK code, and I tightly monitor the releases. If you follow me on Twitter, you'll know that I try to always post on Twitter as soon as a new version of the CDK is out, for exactly this reason, because my fear is that if you sit there and you wait 6 months to do a version on your CDK, then when you do have to do that update and you do have to pull it 40 versions, 50 versions ahead, the amount of work that you would have in front of you would be enough that you go, oh, no, like that's, and I wouldn't want you to lose all the benefits of the CDK because of that. So in my mind, keep up with it, make it even part of a sprint task, make it part of every sprint to just, hey, let's make sure that we're up to date on our CDK. In most cases, that would be a 1-point task most of the time. Occasionally, it might be a 3-point.
I'll also make a plug. There's a website, newreleases.io, that you can subscribe to, and then it emails you out like updates to CDK. I find that very helpful, because it also includes like all the things that the bug fixes and the features in that release. So
that was the other thing I was going to mention. The reason why I like using progen for my CDK projects now is because it will very easily add a Dependabot in there. So if I'm using GitHub, which I do for all my stuff, Dependabot will tell me when a new version is out, and it'll set up a PR for me, and I can check out that PR, synth, run my tests, and everything looks good. I just merge in and I'm done pretty much. It's a little bit more difficult than that, to be honest with you, because the way the progen handles CDK versioning, but it's a lot easier than having to sit there and try to maintain the stuff myself. So that's a big push on the progen. And by the way, progen, developed by a guy named Elad Ben-Raziel. He's the product manager for the CDK. And he basically took the lessons learned from the CDK and turned that into a tool for managing your products. So here is a construct for an AWS CDK TypeScript app. And I give it things like the version of the CDK that I want to use. Notice here, I'm like 6 versions behind on this stuff, because I think I started working this up like 3 or 4 weeks ago. I tell it whether I want to be version pinned. I tell it all the other sort of information, like what other CDK dependencies I want to bring in. And then through a very simple command line, look, I got a lot of options on how I want to modify this. And then when I run the progen utility that synthesizes this into it, it'll synthesize out my git ignore, my mergeify, my npm, my ESLint, my GitHub workflows and Dependabots. It automatically puts workflows in here for doing publishing to npm, to PyPy, to all those guys. So really, really handy tool. Big fan of it. If you've been watching anything around either progen or CDK or Terraform for CDK, you'll know that this construct API is becoming pretty popular and is very, very powerful for handling a lot of things that have been notoriously painful in the software development world for years.
When it comes to version changes, I can understand how a version change, you need to fix your unit test or maybe fix a little bit of syntax. But do you ever get in a world where, because of the way that a construct is changed, under the hood CloudFormation can no longer do a change set, and you actually have to do a kind of a destroy and recreate, because I could see that being a bigger headache than just fixing your syntax.
Right. I haven't personally run across that yet. Most of the time, if I ever notice any breaking changes between versions, it's mostly around property name changes or a slight restructuring of the property names, or maybe they'll deprecate a property and replace it with a new one. But I've never run across a time where I made a bunch of changes and it resulted in some CloudFormation change sets that were unapplicable to my existing stacks. I haven't run across that yet. And one thing they do say, so if you go and you take a look, let's see here, trying to think of one that I know is in experimental. I think the pipelines might still technically be experimental. Yeah. So if you come across any of these modules and at the top they have this big developer preview, that's your warning to know, okay, this is probably could potentially change underneath of me and cause me a little bit of rework later. Whereas if I go and I take a look at the EC2, it's considered stable. You can pretty much instantiate anything out of here, and you're not going to probably have a breaking change later, unless there was something really, really fundamentally changing in CloudFormation, which I can't really imagine happening. So you can quickly adopt these things. You know, in the future, they'll probably have a Windows, Bash and Windows host and other things like that, but they're not going to be changing existing APIs much on any of the stable stuff.
Could you say something about the programming languages that you can use for this? You're using TypeScript. Is that the most common one, or is it pretty much depending on your preference and skill sets? So
TypeScript, JavaScript has, according to some community surveys that I've run, is the most popular. About 3/4 of the respondents that I had for about the last year of surveys I've given, most people are running TypeScript. I haven't run across anyone who's doing JavaScript, to be honest. It's usually, I have TypeScript, it gets compiled into JavaScript, but you never really know that when you're dealing with the CDK. Python is the next most popular. It takes up almost 1/4. I think I had one respondent last quarter say that they were using Java, and I haven't run across anyone that's using .NET. Now, that's not to say that they're not good languages to use for it. Personally, I would say that if you're doing a server full application, RDS, EC2 instances, ASGs, those sorts of things, it's probably irrelevant what language you write it in. Whatever you're most comfortable with, whatever the maintainers of those CDK apps are most comfortable with, is going to probably be your language of choice. If you're writing serverless applications where you've got Lambda functions, where you've got really just Lambda functions you're going to be writing all over the place, you'll probably want your CDK code to be in the same language as your Lambda functions. It just makes the context switching a lot easier along the way. So if you're writing your Lambdas in .NET, you probably want to use the .NET for the CDK. You certainly don't have to, but again, it'll probably make development world a little bit easier. It also comes down to, if you've got DevOps engineers, I'd be willing to bet that they probably came from more of a sysops world, in which case they don't really know much about programming languages, maybe. In which case, again, whatever you think is easier for them to pick up, that's probably going to be TypeScript, but not a guarantee. But if your DevOps engineers came more from the application space, they're probably going to lean towards whatever language they wrote their applications in. So you got the freedom, use whatever you want. I don't think there's really any downside one way or the other.
So
I've always used TypeScript. I think I tried one time in Python, but yep.
So I want to jump in and just actually to give Matthew a heads up. So we do a raffle, and I actually am going to ask a question about the raffle, but the raffle question is a trivia question. So Matthew, I'm going to ask you to think of a trivia question. You can make it a Star Trek trivia question if you want. But here's the question for the whole group. We've been giving away AWS credits. We've been, with Jen, giving away Audible credits. But I've noticed that people don't seem all that jazzed about it. We've wondered about trying to get some sponsors so we could do some Amazon retail, credits to give out. I've also thought, I really miss reInvent, which means socks. And I was looking into getting some Boston AWS meetup themed socks. So if people, I'm gonna unmute everybody, mute all, and then I'm gonna unmute. How can I want to unmute. Oh, come on. I can't unmute.
I don't believe you can unmute.
This feels
everyone.
very dangerous.
Oh, okay. All right. Well,
Yeah. I
do
don't think
people,
we turn on an open mic in everybody's room.
okay. All right. So I'm not gonna do that,
I,
but
I believe that they don't allow you to unmute because it's a security concern. You're violating their privacy.
Yeah, it's a
Oh,
privacy
okay. All right. So anyway, however you want to, would you be interested in Boston AWS Meetup socks as swag, or what would you like? What would people like for swag or not like?
I love anything custom like that. That's pretty cool.
Stickers are good. Thrown out there.
Well,
Although
okay.
a lot of it doesn't matter anymore because we're never together. You're like, how the hell are you going to see my cool socks?
I'll take
Well,
a beer.
I have all these stickers, but I can't get them to you.
Right.
Well, you know,
Yeah, I would second that one, Kevin. I was thinking maybe baseball caps or beanies or something like that, you know, because at least then you see it in the Zoom.
well, I will say that one of our fellow heroes, Vlad, is really into shoes, and he said the worst thing about the pandemic wasn't the million deaths; it was that people could not see his shoes. And so I said, so you see this OBS thing that I have for my image. I set him up with the thing where with multiple webcams. So you had one webcam on him, one for his presentation, and one for his shoes. So, you know, so there you go. So, all right. So I'll take that under thinking about that. So Jen isn't here, so I'm not sure whether we can find an Audible credit or an AWS credit, but so what we do is, Matt, if you toss out, if you say your trivia question and then type it, answers, type it in the chat, and the first one, Matt, you got to say who got it first wins, and then I'll give you the choice of an Amazon credit or an Audible credit.
Okay, so this is a trivia question that I kind of had batting around in my head. I don't know if it's any good, and I'm going to declare the winner based on my favorite answer, not necessarily the most correct one. So you'll have to be creative. What is the cheapest way to store 128 bytes of data in AWS?
Cheapest, not most expensive.
Yeah, what's the cheapest way to store 128 bytes of data?
Damn.
Parameter store, okay. Parameter store, Route 53, parameter, account names. Oh, I like account names. IAM user. Kevin, expand on that a little bit.
You were able to put tags on it, so right there you can get to the 128, and it's free, so it's hard to beat free.
Okay. SQS, EC2 instance, free tier, and use the description. Okay.
That's a good one.
EBS. Okay. The Lambda event queue. Wow, Tom is a jerk. All right, any more guesses?
He's not replying to that.
Yeah. Any more guesses? Going once? Going twice? All right. So let's walk through these real quick. I like the idea of a parameter store. If I remember right, parameter store is pretty cheap. I don't think it's totally free, but I think it's fairly cheap. It's certainly cheaper than Secrets Manager. Account names, that's a good one. I don't know if you can get 128 characters into an account name, but I like that one a lot. That's so far probably in first place. IAM user, again, great. Definitely hacky. The tags is interesting, but you still have to have a tag on a resource, and you probably have to pay for that resource. So I'm a little.
No, I would put the tag on the IAM user, which
on
is
the IAM user. Okay. S3, EBS, EC2 instance with the free tier. I'm not trying to pay favorites here, but I like the Route 53. There's something about using DNS as a public database that I just always thought was really clever. So if I got to pick a first place, it's going to be Patrick, and if I'm going to pick a second place, I'm going to go with the IAM user. Actually, excuse me, the account name. The account name I think is great.
Yeah, Route 53 text value. I mean, you can stuff a big chunk of data in there.
Yeah, and the distribution is super easy.
Oh, easy.
Ever since Corey has brought up the whole Route 53 as a database thing, I've been wanting to make a SQL like what is it called? Something to query a SQL database in code, but I've been wanting a SQL connection thing for Route 53 so that you could just use that to you wouldn't be able to do any joins, I don't think, but you could do, selects off of it all day.
Yeah, if you get control over subdomains, though, you can segment your data using a subdomain.
Yeah.
So Patrick, would you like an Amazon credit or an Audible credit?
Let me go with the Amazon.
Okay. Send me an email, Brian Tarbox, all one word, @gmail.com, and I'll send you the code.
All right.
Okay, and I'll just say our next meetup in 2 weeks is developer advocate AJ going to talk about AWS Cloud for .NET, which is sort of a whole different thing for us. I mean, I don't know. I'm going to go. Well, obviously I'm going to go because I'm running the thing, but just to learn. And then we've got a bunch of ones after that. And I want to say thank you, Matthew. It's as always great to see you. This is fabulous. And yay, this is my 10th meeting of the day, and I am now done.
Ouch.
Well, thank you everybody for coming. I hope you learned something. I hope you saw some power of everything. If you want to follow me on Twitter @Matt Bonig, that is definitely a place where I probably tweet out a lot more about Star Trek than you want to hear. But if you can, go through it, then, occasionally I talk about something CDK related.
Thank you, Matt.
Thank you.
All right.
Great
Take
talk.
care, everyone. Thanks, man.
Thanks, everybody.